Welcome back. Let's dive right into episode 25 of this explainer. Today we're going to completely strip away the magic of artificial intelligence. You know, it's so easy to look at the incredibly human-like text or those stunning images AI generates and just assume there's a ghost in the machine, some conscious creative mind hard at work. But today, we're looking past the interface. We're going to examine the physical wires, the silicon, and the hard mathematical realities running the show. We're talking about what we call the von Neumann Babblefish.
So you really have to ask yourself, and the philosophical stakes here are just fascinating. When an AI writes a poem or codes a website, is it actually creating? As we'll see throughout this explainer, AI is fundamentally just an advanced translator. It's a mechanical mediator that orchestrates meaning, sure, but it relies entirely on human origination.
Here is our roadmap for today. We'll start with the von Neumann bottleneck, then look at discrete tokens and continuous meaning. After that, we'll explore the universal Babblefish, tackle the illusion of creativity, and finally wrap up with the human authorial crux.
All right, let's jump straight into Section 1, the von Neumann bottleneck.
Okay, so since 1945, nearly all computers have been built on the von Neumann architecture. This physically separates the processing unit from the memory unit. Now, for conventional tasks, like running a spreadsheet or playing a video game, this flexibility is absolutely fantastic. But for AI requires evaluating billions of mathematical parameters for every single word it generates. So this physical separation creates a massive grinding data traffic jam known as the memory wall bottleneck. The processor literally just sits there idle, waiting for model weights to be shuttled back and forth from memory.
Engineers are desperately trying to solve this massive hardware problem. Take standard GPUs. They waste an immense amount of time and energy just physically shuttling data back and forth. But newer paradigms are emerging. Things like analog in-memory computing are trying to eliminate that commute entirely. They actually perform calculations directly inside the memory array, using Ohm's law and the physical properties of the materials themselves. The data doesn't move, it stays stationary. It's a huge shift.
Here's the crazy part about all this. Moving data physically costs real energy. To send a simple 1 or 0, you actually have to charge and discharge a physical copper wire. And the longer the wire, the more energy you burn. Because of that von Neumann bottleneck, AI spends most of its massive power consumption just shuffling data across those wires, rather than actually computing or thinking. It is physically bound to the limitations of silicon.
Moving up the stack, we arrive at Section 2, Discrete Tokens, Continuous Meaning.
Deep inside an AI, concepts exist in what we call continuous vector spaces. Think of it like a smooth, fuzzy, multi-dimensional map of meaning, where concepts just naturally blend together, very much like human associative thought. But here is the rub. Digital computers can't handle smooth, continuous concepts. They are forced to chop that continuous meaning into rigid, discrete ASCII tokenization. This creates a severe friction point, a massive modality mismatch between the fluid meaning the AI wants to map and the rigid digital chunks it's forced to output.
And this tokenization process perfectly illustrates why large language models can fail so spectacularly at basic math. Algorithms like byte-pair encoding literally break numbers into arbitrary, non-decibel chunks. So to the AI, pi isn't a continuous mathematical concept, not at all. It's a fractured sequence of subwords, the number 3, a period, the number 14, and the number 159. It has absolutely zero foundational concept of place value logic.
Because of this discrete tokenization constraint, the AI essentially has to memorize arithmetic as associative text sequences, and man is it fragile. Even a simple trailing space or a capital letter can completely derail its logic. To the machine, lowercase good and uppercase good are two entirely unrelated mathematical integers. This rigid tokenization is an absolute bottleneck for the AI's ability to truly reason.
Which perfectly brings us to Section 3, the universal Babblefish.
If you're a fan of the classic sci-fi series The Hitchhiker's Guide to the Galaxy, you'll know exactly what this is. We can really view AI not as an independent, conscious thinker, but as the ultimate modern-day Babblefish. It's a tool purely designed to ingest one form of information, map it to an internal meaning space, and spit it out in a totally new format.
At its core, generative AI operates on a simple sequence-to-sequence mapping process. It translates English to French, or a text prompt into Python code, or maybe a supply chain dataset into an executive summary. It does all this by mapping sequence A to its continuous vector space and then translating it to sequence B. But remember, it is blindly translating these formats without truly comprehending a single word of them.
The AI is simply a mechanism. It orchestrates meaning, translating human associative thought into structural code. It is an incredibly powerful enabler, for sure. But the actual associative thought, the real spark of intent, originates entirely with the human prompt. You are the source. The AI is just the translator.
Moving right along to Section 4, the illusion of creativity.
To understand this illusion, we have to look at the difference between connectionist AI and symbolic AI. Generative models like ChatGPT rely heavily on connectionist AI. They mimic human creativity by recognizing massive statistical patterns in data. But they lack explicit top-down logic. They're these opaque black boxes that basically just guess what sounds right. This is exactly why researchers are working so hard to develop neurosymbolic AI to bridge this gap and marry pattern recognition with actual logical rules.
This quote from Noam Chomsky really hits the nail on the head. AI is merely extrapolating the most statistically probable conversational response based on its massive training data. But true human intelligence? We don't just predict the next word. We seek to actively explain the world, to understand cause and effect, and we do it incredibly efficiently with very small amounts of information.
Because AI is mathematically bound to predicting discrete tokens and physically bound to copper wires, it completely lacks the biological substrates required for lived experience. It doesn't have compassion, it has no actual gut feelings, and there's zero unified self-awareness. It completely fails the philosophical hard problem of consciousness. Simply put, intelligence is not the same thing as consciousness.
And finally, let's look at Section 5, the human authorial crux.
As AI starts generating beautiful art, writing scripts, or even designing pharmaceutical drugs, courts around the world are actively grappling with the boundary between human-driven originality and algorithmic outputs. It's a huge debate right now. If the machine isn't conscious, who actually owns the work it produces?
The philosopher Hannah Arendt provides a really brilliant lens for us here. She described true creation as praxis, an active, engaged doing that is completely inseparable from human consciousness and our social existence. Because AI cannot engage in this lived praxis, its legal and philosophical role really remains confined strictly to that of a sophisticated mechanical enabler of human creativity, not a creator itself.
What we're actually seeing is the definition of human authorship evolving from pure origination to orchestration. Think of it like we are becoming modified auteurs. As human creators, we provide the rhetorical technique, the strategic intent, and the prompt. Then we surrender the technical technique, the mechanical rendering and execution, to the AI Babblefish. But the overarching strategy? That remains firmly human.
Now just imagine a future with brain-computer interfaces. You simply think an idea, and the AI instantly renders it into a painting or a symphony. In this scenario, the AI acts as a genuine prosthetics of the human mind. It's a pure translator of our most intimate, preconscious thoughts directly into digital media. It's the ultimate proof that the AI is merely the brush and you are the painter.
I'm going to leave you with that provocative thought. Today, we've stripped away the magic to see the underlying von Neumann architecture, the tokenization limits, and the reality of the Babblefish. The big question now is, how will you use this incredible translator to orchestrate meaning in an algorithmic age? Thank you so much for joining this explainer.